Hello, everybody. Today we are going to be talking about what happens when we have to add or subtract angles when we are in the trig unit. So before we begin with all the formulas that you see on this paper, we're going to go back to the Pythagorean identity because just like about 80% of the work we've done already in the trig unit, it always is going to go back to the Pythagorean theorem. We just can't get away from it. Remember, sine is on the unit circle y, so that's the altitude because that's how far up you go to get to the point. Cosine is the x on the unit circle because that's how far over. So this is the altitude, this is the base, unit circle, hypotenuse is 1. And so if you always keep in mind that this Pythagorean identity is the same thing as the Pythagorean theorem, you're in business. Because now you get to exercise 1. Angle theta has a terminal ray in the second quadrant. Now, the minute you read that, this is when you're saying to yourself, okay, I am only in quadrant 2. So here's my graph. If I could, I can't even draw with this thing properly. And here's quadrant 2. I don't want any other quadrant right now. This is all I need. Here's quadrant 2. Done. Now my y is positive. All right, let's try this again. My y is positive. So my sine is positive. My x is negative. So my cosine is going to be negative. Now they're telling me that the sine of the theta is 5 to 13. So this is the opposite side, and this is the hypotenuse because I'm not on the unit circle. This one has to be drawn. So if I now draw this angle, here it is, quadrant 2. This is telling me that this theta came from an opposite height of 5 to a hypotenuse of 13. So now, if I want to find the base of this triangle, I would be using the Pythagorean theorem, which is going to tell me 5 squared plus base squared is equal to the hypotenuse squared, which is 13 squared. Now, you can do this on your calculators. You eventually get to the base squared is equal to 144. So you can always stop the video and you can type those things in. And then the square root of 144 tells me that the base of this triangle is 12. And I went a distance of 12 in the negative direction. So remember, this 12 over here came from heading in the negative direction. So now my cosine of theta is going to be the adjacent to the hypotenuse going in the negative direction. So now cosine, and we've been doing this, ladies and gentlemen, since lesson 3 of chapter 9. So you hopefully by now, I am really hopeful that you are super comfortable with the Pythagorean theorem because that is what this entire next chapter is all about. If you could do the Pythagorean theorem and you can match which formula you're going to need, you can add or subtract angles because it's all about what are you doing? Are you adding the angles with sine? You follow this formula. If you're subtracting with sine, here's your formula. You're adding with cosine or you're subtracting with cosine. So as long as you can match, and our values are going to come from, you know, the Pythagorean theorem or the special right triangles that we have memorized, we're going to be in business. So let's take for a moment and let's, you know, pull together so many different things that we know. First, the sine is 75. If I was going to think about the sine of 75 degrees in terms of adding or subtracting, And this one, the directions say simplest radical form. So that's telling me I am going to think about adding, because the sine of 45 degrees plus 30 degrees would make 75 degrees. 45 degrees is a special triangle, and 30 comes from a special triangle. So if you go back in your notes and you pull out those tables where we had the sine, the cosine, and the tangent of 30 degrees, 60 degrees, 45 degrees, then you're just going to access your notes and it becomes quite simple. You don't want to have to figure these things out every single time. So please, your notebooks are so important. We made the table really neatly back in chapter 9, lesson 3, day 2. Go back to those notes or even the video, take a picture, copy down something, have your tables so you can use them easily. So now if I'm going to follow this, 45 is my A and 30 would be my B. So this would now come from the sine of 45 multiplied by, we are multiplying now, so I'll use the multiplication sign, by the cosine of 30. And then we're going to add to that the sine of 30 multiplied by the cosine of 45. So I hope you stopped the tape and you went back and you found your tables of all these special angles and triangles that we should know. And if you did that, here we go. I'm actually going to use the pen. I think it'd be easier for me to do that. The sine of 45 from our table is rad 2 over 2. And I'm going to multiply this by the cosine of 30 degrees, which is rad 3 over 2. Now this gives me, if I multiply this side together, see I didn't hit the plus sign yet, but if I multiply these two together, I now have rad 6 over 4. Now the sine of 30 is 1/2 from your table. And the cosine of 45 is rad 2 over 2. So now these two multiplied together is going to give me rad 2 over 4. So in the simplest radical form, the radicals don't match, so I have to keep the radicals separate. That brings us all the way back to chapter 3, with a little nice review on radicals. So here I'm going to add rad 6 and rad 2 all over my common denominator of 4. There you go. So it's a matter of just plugging into a formula. Does it look intimidating? Of course it does. Every time you see something new, it's intimidating. But if you take your time, you are able to do everything. We have covered every single thing you need. And everything's in the videos since we've been on distance learning. So please, please look at the videos. Now here I want cosine of 15. Now think about it. 45 and 30 add up to 75, but 45 minus 30 make 15. And now it's cosine of 15, and we're going to be subtracting. So here's the formula we're going to use. Let's write this out. Cosine of 15 degrees is the same as the cosine of 45 minus 30 degrees. Now, if we follow the formula, this is the cosine of 45 times the cosine of 30. And now we're going to add that to the sine of 45 times the sine of 30. We're using the same values. We're using that same chart. So let's do that now. Go back to my pen. It's easier to now write. The cosine of 45 is rad 2 over 2. Cosine of 30 is 1/2. Cosine of 30 is rad 3 over 2. Well, this is exactly like this up here, isn't it? This gives me rad 6 over 4. And then I'm going to add the sine of 45, which is rad 2 over 2. And the sine of 30 multiplied by the sine of 30, which is 1/2. And this is now rad 2 over 4. So now I have the same answer. So two different problems, two different formulas, landing me in the same place, but that happens all the time. We can get the same answer for two different problems. And there we go, over 4. So I hope that you followed along with this one. Now, it does get intimidating, especially when you're on your own and I'm not here helping you. So just remind yourself, before you panic, remind yourself that you're really smart. You can take your time, you can go slow, and if you need to, just shoot me a message. I'll answer you, I will help you out, and that's really all you need to know. Now let's take a look at this guy. Again, it looks scary. Breathe. We have 4 formulas. We're going to plug into different things, but let's go slow. First, for angle alpha, if I'm between 0 and 90, then that means alpha is in quadrant 1. So let's draw a little graph. Here's my x, here's my y, and here is angle alpha. Now, they're telling me about alpha in terms of cosine. This alpha angle has an adjacent of 3 and a hypotenuse of 5. So if I drop my altitude, my base is 3, adjacent is 3, and my hypotenuse is 5. And now, Pythagorean Theorem. I don't know the altitude yet, so a squared plus the base squared, which I'm going to go straight to 9, equals the hypotenuse squared, which would be 25. So you can always go slow, stop the tape to do the Pythagorean Theorem slower on paper if you need. I just don't want this video to last forever. So you subtract a squared from both sides, and you get that you have the altitude squared is 16. To solve for the altitude, we square root, and then that makes our altitude 4. So now the side opposite is 4. All of this is super important to do. So that's why I beg you to go as slow as you can go. Now, angle beta is bigger than 90, less than 180. That means angle beta, let's just draw this over here, he is in quadrant 2. So this is quadrant 2. And here's my B. And if I draw my altitude, my sine is opposite over hypotenuse. So opposite is 7, and that is going in the positive y direction. Wow, that's a bad y. So that's a positive 7. But now, when I look for the base with the hypotenuse of 25, I need to remind myself that the base is heading in the negative x direction. So when I find this value here, when I talk about cosine, I'm going to be, for beta, negative. let's again, Pythagorean Theorem. Now again, you're welcome to stop the video. I'm going to go fast. This again, altitude squared plus base squared is equal to 25 squared. So by the time you're done with the Pythagorean theorem, we find that the base of this triangle is going to be equal to 24. Again, feel free to do all the work out. Now this is 24 in the negative direction. So letter A, find the sine of alpha. Okay, here's alpha. Sine opposite to the hypotenuse. This one is nice and straightforward. You should get 4/5. Now, they want the cosine of beta. Well, beta is 24 heading in the negative direction over 25. So the cosine, the adjacent, is heading in the negative direction. You went out a distance of 24 over your 25. There we go. Now, the one thing I want you to notice is we now know the sine of beta and the cosine of beta. We now know the sine of alpha and the cosine of alpha. And all of our formulas now are going to deal with these 4 ratios. So if we now wanted to know the sine of alpha minus beta, so the sine of alpha minus beta would come from the sine, and I'm not going to use the fancy script, I'm just going to use the regular keyboard. The sine of alpha times the cosine of beta minus the sine of beta times the cosine of alpha. And from here, we're going to plug in the values that we have. Actually, I'll put the little equal sign here. So there we go. So now if we plug in our values, the sine of alpha is 4/5. And the cosine of alpha was 3/5. I'm just going to fill in my alphas. And I'm going to color code it to maybe make it easier to read. Now, the cosine of beta was negative 24/25. And the sine of beta is 7/25. Now, we are multiplying these 2 fractions together. We're multiplying these 2 fractions together. And then we are, according to the formula, subtracting. So when I multiply this, I get negative 96/125. And when I multiply this, I get negative 21/125. And so this final answer for part C is negative 117/125. Again, the look of these problems very intimidating, but the bottom line is you could do the Pythagorean theorem. All you got to do is drop the ratios, and your calculator can multiply the fractions for you and add the fractions for you, and then you're done. I mean, it's really a matter of find the formula, drop in the right ratio. So for the cosine of alpha plus beta, this again, you look above to the top, this is going to come from, and I'll just, right here, this is going to come from cosine of alpha, cosine of beta. So cosine of alpha times the cosine of beta minus the sine of alpha sine of beta. And we're going to take these same four fractions, and now we're just typing them in this way. So the cosine of alpha was given to us as 3 over 5. So here's my 3 over 5. The cosine of beta, right here, negative 24 over 25. So these two multiply together, and these two equal negative 72 over 125. Now from here, I'm going to subtract the product of these two. Sine of alpha is 4 over 5. Sine of beta, right here, 7 over 25. And that's going to give me 28 over 125. So that will give me now a final answer of negative 100 over 125. And if you were to put this in on your calculator and hit enter, you would get a decimal, and then you would hit math, enter, enter, and that would reduce this to negative 4/5. So if you can reduce, you must. Now look at, depending upon if I was sine or cosine, add or subtract, the same four ratios here gave me negative 117 over 125, and here I got negative 100 over 125. And we're going to get different answers here as well. This one says the sine of 2 alpha. What this means is, this is the same as saying the sine of alpha plus alpha. So I have the sine and I'm adding. So this is going to be the sine of alpha, cosine of alpha, plus the sine of, I'm sorry, I wrote that a little too fast. This is going to be, no, I'm sorry. Duh, now I am getting tongue-tied. This is now going to be the sine of alpha, cosine of alpha. I'm just going to move this down so it doesn't see, and this is because instead of the beta being here, which this would have been a beta, beta, 2 alphas, alpha plus alpha made everything. So this is all my sine of alpha and my cosine of alpha, 2 times. Now, you look up here, my sine of alpha is 4 over 5, and my cosine of alpha is 3 over 5. So this is going to give me 4 over 5. times 3 over 5, which is 12 over 25. And now I'm going to add this to, look at that, same thing, 4 over 5 times 3 over 5. And that's 12 over 25 and 12 over 25 added up gives me 24 over 25. So sloppy, but you get the point. Now we're going to do the same thing with cosine of 2 beta. Cosine of 2 beta would go from the cosine of beta plus beta. And if we follow the formula from above, this would be cosine beta minus sine beta. So this would then be cosine beta minus sine beta So you're basically squaring cosine beta and you're basically squaring sine beta. So the cosine of beta was negative 24 over 25. Which was, when you multiply it, positive 576 over 625. And now from this, we're going to subtract the sine of beta, which was 7 over 25 times 7 over 25. That means I'm subtracting 49. Wow, I got to fix that. That's too sloppy. All right. There we go. 49 out of 625. And this one is going to give me 527 out of 625. And finally, we get to the last one on here. It tells us, oh no, last two, excuse me. Which of the following is equivalent to? Now you have the cosine of 100, cosine of 20, sine of 100, sine of 20. Now you look up at the formulas and you notice that this is matching with the cosine of A minus B, where your 100 would be your A angle and your 20 would be the B angle. And so this is going to go with the cosine of 100 minus 20, because the cosine had the opposite, like it said plus here, but in the beginning part it would have been minus. So this guy here would have been cosine of 80. Now, the last one's a little bit of a challenge because I want to know which of the following is not equal to the sine of 70 degrees. And this guy here has a squared on it. So this one's telling me, you know what, they used the Pythagorean identity. They were using sine, whoops, I'm going a little too fast, sine square, I got to write that again. I'm sorry, I went a little too fast. Actually, I think I might type this one. It's a little too hard. All right, so this one would have been sine squared of 70 degrees plus cosine squared of 70 degrees is equal to 1 whole. That's the Pythagorean identity. Now, if I want to see what's equal to the sine of 70 degrees, then I would subtract cosine squared from both sides. So that would give me then the sine squared of 70 degrees is equal now to 1 minus the cosine squared, because I took cosine from the left and I moved it over to the right. And then if I don't want the squared anymore, then we would have to square root. And if I were to square root, I would have the sine of 70 degrees, and that would be equaling now the square root of 1 minus the cosine squared of 70 degrees. And I'm just going to finish off. And that is this one right here. Come on. We'll move it. There we go. All right. So again, Pythagorean theorem. Altitude squared plus base squared equals 1. And if I want the sine by itself, I subtract cosine squared from both sides. And I don't want the square, I square root. This one is absolutely equal to the sine of 70 degrees. So that one took a little bit of time. Let's take a look at number 2. Cosine of 80, cosine of 10, minus sine of 80, sine of 10, cosine of 80. This one, if you match your formulas from at the top, this one would be equal to the sine of A minus B. So this would be the sine of 80 minus 10. So this one clearly would be the sine of 70. So that one works. Now we look at this. We have sine of 40, cosine of 30, plus sine of 30, cosine of 40. Again, we match this. And this is actually the first formula from above. This is the sine of A plus B. This would be the sine, and my A is 40 degrees. and my b would be the 30, which would absolutely equal 70. So it looks like by default it's number 4. Let's just make sure. Sine of 60 cosine of 10 minus sine of 60 cosine of 10. Well, this one would be the sine of a minus b. So this one would be the sine of 60 minus 10, and that would be the sine of 50. So if I were to put this in, this would have been 60 minus 10, which would have given me the sine of 50 degrees. So therefore, number 4 is not equal. So I took my time, I used Pythagorean theorem, and then after that, it's a matter of plugging into a formula. And I know you guys can plug into a formula. So it looks intimidating, but I feel very strongly that you can plug into these 4 formulas. Just take your time and do your best. And again, let me know if there are any questions at all.